Well, hello, this is the second video in a sequence on solving logarithmic equations. The first video explored some pretty easy and basic problems. The problems today, though, are going to require us to be aware of at least two logarithmic properties, and here they are. One of them is that if you're adding two logs of the same base, that could be substituted with a log of a product of the arguments of those logs. If you're subtracting two logs of the same base, you can write that as a single log of the quotient of the arguments of those logs. And then at least once today, we're going to come across a quadratic equation of this form that won't solve very well by factoring. And so we're going to be using the quadratic formula at least once today. That's the introduction. Now let's solve some problems. Okay, this first one has a couple of base 2 logs and they're added. So remember, we can write that as a single base 2 log where the contents of those logs are multiplied together like this. And that's still equal to 3. Distributing that x, I have base 2 log of x squared minus 2x is equal to 3. Now, if a base 2 log is equal to 3, that means 3 is an exponent. And in combination with this base, in other words, 2 to the third power, I would get the value inside that logarithm. So x squared minus 2x equals 2 to the third power, which of course is just 8. Now here's a quadratic equation. Fortunately, we won't need the quadratic formula for this. All we have to do is get it equal to 0, and we'll find that it's quite factorable. Subtract 8 from both sides. That looks like this. And then just find a couple little binomial factors. And I believe for negative 8, you're going to want to use minus 4 and plus 2. And then the roots revealed are, here is a 4, and here is a negative 2. Now, before submitting your assessment to the instructor, remember, these have to be able to plug back into these logarithms without violating any rules. And this negative 2 presents a problem because if you take the base 2 log of negative 2, you're not going to get a real answer. And so it turns out this is a bad or false or extraneous solution. So x equals 4 is the single solution for this problem. Problem 2. I'm adding logs again. So I think what I'll do is write this as a single log of the product, 3x squared times 3. But 3x squared times 3, of course, is 9x squared. So I have the base 3 log of 9x squared is equal to 2. Now, there are different ways we can go from here, but I'm just going to go ahead and apply the definition of logarithm to say that, okay, this base raised to that exponent equals the contents of the logarithm. So 9x squared equals base 3 raised to the 2 power. And that's 9. Now I divide both sides by 9 to arrive at x squared equals 1. But of course, there's two solutions to that. There's the plus 1 and the minus 1. So solutions are 1 and negative 1. You can go back and make sure that these really work in here. The only one that scares me is the negative 1. And yet, if you put it in here, you're squaring negative 1. And so you won't be in violation of any kind of, don't take the logarithm of a negative rule. These are both good answers. 1 and negative 1. Third problem. This one turns out not so nice. Now, this is a natural log, so it's based on the base e, or roughly 2.72. But like all logarithms, if you have the same base in a logarithm and you're adding these two logarithms, you can write them as a single log, and that would look like this. Then I would distribute the x to get natural log of x squared plus 3x is 4. Now, if you want to extract the contents of this logarithm, what you're going to have to do to solve it, you're going to have to remember that this log is based on e. This is a base e logarithm. And what that means is that 4 is the exponent raised above a base e to make x squared plus 3x. So this is a valid equation. Get it equal to 0, which is what you should do with quadratic equations. So that's x squared plus 3x minus e to the 4th equals 0. And then I think from here your best bet is to go use the quadratic formula. So we need an a value, which is 1. We need a b value, which is 3. And we need a c value, which includes that negative. And we're going to inject those into, remember what it looks like? Quadratic formula. All right, so we have x equals the opposite of b over 2 times a plus or minus the square root of b squared minus 4 times a times c. And then divide by 2 times a again. Okay, so this is negative 3/2. You could just as well write negative 1.5. This is clearly a 2. And this is 9, and then a minus of a minus is a plus, so I end up with square root of 9 plus 4e to the 4th. And there's really no way to simplify that. So that represents 2 answers. Are those answers good? Well, let's go consult the calculator here. And there they are. One of these is about negative 9, and one of these is roughly 6. Okay, keep that in mind. The one that came out to negative 9 had a minus here. The one that comes out to 6 has a plus here. Are those both good answers? No, the one that has negative 9, you can't plug it into here or here either for that matter. Whereas the one that came out to about positive 6 is valid in both of these. So I think what you need to do is throw away this minus and just go with the plus. So my answer is negative 3/2 plus the square root of 9 plus 4e to the 4th, that radical over 2. Answer. All right, moving on. Problem 4. This is something different. We have a minus here. Okay, do we remember the log property that says what to do when you're subtracting 2 logs that are both, in this case, base 3? Here's that property again. It says you can combine those 2 logs into a single log, but this time it's a quotient, not a product. So I will write, to get this started, base 3 log of 12x plus 6 over 2. 12x divided by 2, of course, is 6, and 6 divided by 2 is 3, so I have a base 3 log of 6x plus 3 equal to 1. That means 6x plus 3 is equal to this base raised to this exponent. Logs are exponents. Well, here's an equation with 3 on both sides, and if I subtract that from both sides, I get 6x equals 0, which of course means x equals 0. And you can go back and check. That doesn't cause any problems up in here, and so I believe that that's our answer. Now, sometimes when you get an answer, and you're pretty sure it's a good answer, it's fun just to plug it back in and show that it really works. So this is not necessary, but I thought we'd do that right now. What happens when you plug 0 into this equation? So you have base 3 log of 12 times 0 plus 6 minus the base 3 log of 2 is equal to, and let's put a question mark on that because we don't really know that this works. We just think it works. 12 times 0 is 0 plus 6 is 6, so this is the base 3 log of 6. And this is the base 3 log of 2, and I'm subtracting them, and supposedly that's going to come out to 1. Are we sure? Yes, it is, because remember, when you're subtracting logs, you can take the log of a quotient. So that would be base 3 log of 6 divided by 2, and 6 divided by 2 is 3, and the base 3 log of 3 is indeed 1. Check. So the 0 works, and we just confirmed it. Okay, here's a problem where, again, we're adding logs, and so what we're going to do is combine this into a single log where I'm multiplying the x minus 9 and the x minus 3. And this is equal to 2. squaring out these, not squaring, multiplying these binomials. I'll go pretty fast with that because I think you students are sophisticated. Yeah, you get x squared, you get minus 3x minus 9x is minus 12x, and then negative 9 times negative 3 is positive 27. And so if the base 3 log of this is equal to 2, then the contents of this log must be equal to the base 3 raised to 2 power. And it is. 3 to the 2 power is 9. And so if I subtract 9 from both sides like this, I get x squared minus 12x plus 18 equals 0. Now, how am I going to solve this? I'm going to do it just like I did before. I'll put a 1 here, and I'm going to say that a is 1, and that b is negative 12, and that c is 18, and I'm going to go ahead and fill in the quadratic formula. And that's going to look like this. It's the opposite of b over 2 times a plus or minus. The second fraction is also divided by 2 times a. And in its numerator, I have this big square root of b squared minus 4 times a times c. And you can finish this with a calculator if you wish. But this is supposed to return our values of x, so I should have put x equals. Okay, opposite negative 12 is 12 divided by 2 is 6. Over here, I get 144 minus 72. That makes square root 72. But inside of 72 is a big perfect square called 36. So let me write this as 6 plus or minus square root 36 times the square root of 2 over 2. And the square root of 36 is 6 divided by 2 is 3. So I'm left with 6 plus or minus 3 square root 2. Okay, do these both work? The answer is they do not. So why not? Well, because with the plus here, you certainly get something large and positive, and that's not going to cause a problem with either of these. But I believe with a minus here, you get something that's small enough to be overwhelmed here and make a negative. So the answer to this one is just 6 plus 3 root 2. And you can try that out if you want. Try the minus, try the plus. Yeah, the minus here is not valid, so just go with that one. All right, and then finally we have a problem where, again, we're subtracting 2 logs that have base 4. So I write this as a single log of 2x cubed minus 12x squared over 2x. The difference of logs is the log of a quotient. And this was designed to come out pretty nice. When you divide these here, you just get x squared. And when you divide these here, you get 6x. Now this base 4 log equaling 2 can only mean that x squared minus 6x is this base raised to this exponent. And 4 to the power of 2 is 16. So you subtract 16 from both sides, and you get x squared minus 6x minus 16 equals 0. That is factorable. And the factorization is x minus 8 and x plus 2. Now the results are, the root here is 8 and the root here is negative 2. Do they both work? Well, clearly the negative 2 is not going to work there, because 2 times negative 2 is negative 4, and we're not taking logs of negative numbers. So you can throw that one off the list. And then if you want, plug 8 back in here, and you'll find out that it's a good solution. Well, there we go. 6 problems, solving log equations. I hope you learned something today and enjoyed this. My name's Eric. Have a good day.